Hello, I'm Gary Frankenberry from TechStorms Productions, and this is Tutorial 5 of the Ruby Programming Series. Let's take a quick look at the lesson outline. Today we're focused on numbers, which is one of the 6 major data types in Ruby. The other major data types include strings, numbers, booleans, arrays, hashes, and symbols. Today we'll consider numbers, specifically integer numbers. We'll also look at both input and output of both strings and integers. And finally we'll look at numeric operations in Ruby, specifically addition, subtraction, multiplication, division, exponentiation or raising a number to a power, and modulus. The numbers data type is divided into 2 major sections, integers and floating point numbers. An integer is a number without a fractional part, 0, 1, 2, 3, 4, and so on infinitely in the positive direction, and -1, -2, -3, -4, and so on infinitely in the negative direction. A floating point number is any number with a decimal point number. Examples are 3 and 14,159 hundredths, 6 and 0 tenths, -321 and 0 tenths, and -3 tenths. Let's focus for now on just the integers. The integers in Ruby program divide themselves into 2 sections, fixed nums and big nums. Now the integers in computer programming are not an infinitely large range of numbers. For storage limitations and calculation efficiency, some computer systems represent an integer as 4 bytes or 32 bits. Some represent it as 8 bytes or 64 bits. It depends upon the processor and operating system on your computer. These limitations restrict the range from the smallest to the largest integers represented by that data type. Actually, Ruby does not use quite 32 bits or 64 bits to represent integers. Well, it does, but it uses 1 bit to represent the sign of the number, positive or negative, and another bit for internal purposes. So Ruby uses 30 bits or 62 bits to represent the size of the fixed num integer. So the magnitude range of integers on Ruby for a 32-bit system is from approximately -1.073 billion to +1.073 billion. And the range of integers on Ruby for a 64-bit system is from approximately -4.611 quintillion to +4.611 quintillion. Now, big nums will lump together as many bytes of computer memory available to represent the integer. The penalty here with big nums is memory size and computational speed. And of course, you are still limited by the amount of random access memory available in your computer system. Let's consider raising 57 to the 57th power. Now that's 57 multiplied times itself 57 times. Ruby represents 57 as a fixed num, but the power calculation is well beyond the fixed num range. The cool part here is that Ruby automatically and seamlessly converts between fixed nums and big nums, so it's able to do this calculation. Let's take a look at a program to illustrate this. We have a simple one-line program, puts 57 raised to the 57th power. I've already saved it under the name big_power.rb. Also, please note that the star symbol that you see right here in Ruby is called the power or exponentiation operator. That's, of course, 57 times 57 times 57 times 57 times, or in other words, 57 factors of 57 multiplied together. In addition, please also observe the pound sign here. The pound sign is called a comment tag, and when the program is executed, Ruby ignores everything following the comment tag on a line. The comment tag exists solely for the programmer to make clarifying notes on how the code works. Now, if you try running something like this on one of those fancy TI-83 or TI-84 calculators you may have used in high school or college, you would probably get this error message here: error overflow. Calculation exceeds the range of values this machine is able to display. Now, I don't mean to denigrate the wonderful TI line of graphing calculators, but Ruby with the big num integer data type can perform this calculation. So I'll go ahead and execute this program and we'll see what result we get. And we get this fairly long integer here. Well, that's a big answer, but let's take another step. Let's try 157 raised to the 157th power. Executing this program, I get this number here. Let's do it one more time. 1,157 raised to the 1,157th power. I'll press the execute button now, and I get this answer here. Now, this may not look that large, but you realize I have to scroll the window to see the entire number. Here's the beginning of it here. Scrolling down. And here's the end of the number here. Wow. Next, we'll take a look at the difference between strings and numbers and input and output of both.